everyone, welcome to my channel Chemistry is Fun. Today we will study solid state, in that we will study the electrical properties. Now see students, in case of solids, the conductivity can be defined as an electrical property of a material, and the electrical conductivity of the substance can be characterized by its capacity to transmit electrical energy. So if a substance is a good electrical conductor, it can easily transmit energy without altering its composition in some way. And we also find that the solids have different degrees of conductivity. That is, we can also say that all the solids do not have uniform electrical properties. So we find that the solids are of three types on the basis of their conductivity. First one is conductors. They have the conductivities ranging from 10 to the power 4 to 10 to the power 7 mho per meter. And if the conductivity is from 10 to the power minus 20 to 10 to the power minus 10 mho per meter, we call them insulators. And those solids whose conductivities lie in the intermediate range from 10 to the power minus 6 to 10 to the power 4 mho per meter are the semiconductors. So now in detail we see the conduction of electricity in metals. In metals we find that they can conduct electricity in solid as well as molten state. And in metals the conductivity depends upon the valence electrons, whether they are available or not. Now we know that atomic orbitals form molecular orbitals. Same happens in metals also. And in metals, when the atomic orbitals form molecular orbitals, then they are close in energy. So since they are close in energy, they together form a band which is called as the valence band. So here what is happening? All the atomic orbitals of the metals form the molecular orbitals, and when they are close in energy, they form a band. We call this band as the valence band. It is possible that the band is partially filled, that is one situation, or it may overlap with the unoccupied band. This unoccupied band is of higher energy and it is called as the conduction band. If it overlaps with the unoccupied conduction band, then what happens? The electrons can flow easily. Whenever we apply an electric field, the electrons can flow easily and the metal shows conductivity, because flow of electrons is compulsory to show conductivity. So when electrons can flow easily under an applied electric field, the metal shows conductivity. We can see in this figure, students, you see there are two cases. In first one, this is a partially filled band, so here conductivity is possible. Here there is a overlapping bands. Okay, it overlaps with the higher energy unoccupied band, which we call unoccupied band, which is called as conduction band. So the electrons can flow easily. Okay, so this is one case. This is for the metals. Now we will see what is an insulator. Now this gap between the filled valence band and the next higher unoccupied band, if it is large, the electrons cannot jump to that. The electrons are not able to move to that. Then the substance behaves like an insulator. The substance will behave like an insulator. We can see here in this figure. See, there is a forbidden zone, that is large energy gap between the filled band and the empty band. So since it is large energy gap between that, the electrons cannot jump to it, and this is an insulator. Next we have to see in case of semiconductors. In case of semiconductors, the gap between the valence band and the conduction band is small. There is a small energy gap. So some of the electrons can jump to the conduction band, and when the electrons are able to jump to the conduction band, they show some conductivity. The electrical conductivity of semiconductors will increase with the rise in temperature, because when the temperature rises, more electrons can jump to the conduction band. So here you see in this diagram, there is a small energy gap between the filled band and the empty band. So what can happen? Some electrons may jump to the conduction band and show some conductivity. With the rise in temperature, more electrons can jump to the conduction band, and thus they are termed as semiconductors. So examples are silicon and germanium. They show this type of behavior. We call them intrinsic semiconductors. Okay. But we find that the conductivity of intrinsic semiconductors is very low. So low to be of any practical use. So their conductivity can be increased by adding an appropriate amount of suitable impurity. This process is called as doping. Okay. So the conductivity is increased by adding an appropriate amount of suitable impurity. This process is called as doping. I hope students you could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel. Thank you all.